Hello students, today we discuss about waves. Wave nature of radiation. There are two types of radiation, that is wave nature and particle nature. Today we study the wave nature of radiation. Wave nature of radiation. We discuss the various factors related with the wave. First is related with the wavelength. Suppose we have the waves. Okay, these waves will propagate in medium. Okay, waves propagates in the medium, but for light waves, no medium is necessary. Wavelength. In wave, the mountain part, top mountain, that is known as crest, and lower part, that is known as chord. Distance between two crests or two chord, that distance is nothing but it is wavelength lambda. Distance between two crests or two chord here, that is known as wavelength lambda. This lambda, wavelength lambda, is measured in nanometer. Okay? Its light wavelength is very less, so its wavelength we have to measure in nanometer. Second is the frequency. Frequency, the number of waves passing through a fixed point. The numbers of waves, light waves, passing through a fixed point per second, that is known as frequency. So frequency is nothing but, waves means what? Cycle. Frequency is mu, so it is cycle per second. Number of waves passing through a fixed point in 1 second, that is cycle per second. Another unit is known as hertz. Okay, given by scientist Hertz, or discovered by this scientist Hertz. That's why it is given the unit Hertz. Hertz is nothing but it is cycle per second. Why this frequency we have calculated? Because we have to find the energy. The second unit related with the frequency you kept in the mind, E is equal to h mu. Energy of waves is directly proportional to the frequency, and h is nothing, the Planck constant. H is equal to Planck constant. This we study in the later part about the energy of the radiation. But you remember frequency, this E is directly proportional to mu, that is frequency, cycle per second. Okay, hertz. Second is the velocity. Velocity V or C is the velocity of light. Velocity of light in vacuum is 3 lakh km per second. Velocity is nothing but it is what? C. So distance upon time. Distance upon time. Okay, kilometer distance means what? Kilometer. Nanometer upon time means second. Distance covered in unit time, that is known as velocity. Second is wave number. Wave number means what? Number of waves. Number of waves pass through a particular distance, that is known as wave number. Suppose we select the distance and number of waves into that distance, that is known as wave numbers. Okay, it is symbolized by V bar. Amplitude. Amplitude means the maximum distance of this mountain of the waves. Yeah, from center to this top. This distance is nothing but it is amplitude. You have here the name amplifier. Amplifier means what? To increase this wave distance. Okay, this amplitude we have given. Then sound will increases. Okay, if you decrease, then amplifier will decrease. So amplifier will what? Increase the sound level. intensity it will increase. Intensity, another word is intensity, means this distance will increase. If amplifier increases, then waves height will increases. Okay, just like C waves. So that is known as amplitude. So again I revise: wavelength, then nanometer. 1 nanometer is equal to 10 raised to minus 9 meter. 10 raised to minus 9 meter. Frequency we measured in hertz. Velocity, distance per time. Displacement upon time. 3 lakh kilometer per second. Remember this. Wave number, number of waves passing from a fixed distance. Number of waves, how many waves pass from a fixed distance, that is known as wave number. And amplitude means this distance, okay, from the center to the mountain. Here also, this also you can take the amplitude. Another thing I want to tell about this energy. Energy is equal to h mu. H is the Planck constant. Its value is 6.626 into 10 raised to minus 34. Okay, joule. It's constant term. This value and this is the frequency. Frequency E is equal to C by lambda. Okay, frequency we want to find, then if you divide velocity by this, so frequency mu is equal to C by lambda, or lambda is equal to V by C, or C is equal to, in another term, okay, C is equal to mu into lambda. For frequency you multiply with wavelength, then it is equal to lambda. So here you kept in the mind this equation. E is equal to SC by lambda. E is equal to SC by lambda. Then we will get the energy. E is equal to SC by lambda. Okay. Second, we discuss about the property of electromagnetic radiation. Wave nature of the reaction. Second, we discuss that is property. Property of electromagnetic radiation. One thing I want to tell about radiation, that if this radiation is propagate, then what will be its magnetic field and electric field. First, if electric or magnetic field is applied, then these radiations are produced. Okay, so I am drawing one waves. So these are the waves. This is the propagation. Means these waves moves in this direction. Okay. Then if these waves moves in this direction, then magnetic field is perpendicular to it. Perpendicular to it. Propagation is this direction, magnetic field is this direction, then electric field is opposite to this direction. Means like this. If you, so there are three things related with the waves: electric field, magnetic field and propagation. Electric field, magnetic field and propagation of the waves, means movements of the waves are perpendicular to each other. If you forget where is this electric field, magnetic field, then you have to use your left hand thumb rule. Okay, left hand thumb rule. You raise your left hand thumb rule, then suppose this finger, first finger, that is the propagation, then this thumb is the magnetic field and this second finger is the electric field. Electric field and magnetic field is perpendicular to each other, and this first finger means it is propagation. If the waves moves in this direction, okay, then electric field is perpendicular to it and magnetic field also perpendicular to it. Okay, you remember this thing. You can see I am changing the angle, then all angles are perpendicular to each other. I am drawing on the board, then it is perpendicular to this electric field, magnetic field. Okay, electric field, magnetic field, if you draw on the board like, then its propagation must be in this direction. Okay, outside the ball. Electric field, magnetic field, and wave propagation. Second thing, this light waves does not require any medium to propagate. It will move in vacuum also. Third thing is about this radiation. These radiations are in different region. That will discuss about the region or spectrum. Different spectrums are there. We have to study hydrogen spectrum also. This spectrum is nothing but the different region of these waves which have different frequency. Frequency means energy. Lighter energy and higher energy. So these electromagnetic radiations are classified into different region. One by one we will study. Okay. In property of radiation we discussed about the region of spectrum. This light or radiation is classified depending upon the energy or depending upon the wavelength or depending upon the frequency in different region. First region, that is radio. Okay, radio waves, its energy is very less. So radio waves, microwaves, IR means infrareds, visible region, ultraviolet region, X-ray and gamma rays. So these are the different regions. Its wavelength, radio waves wavelength is large, 10⁻². Okay, more waves, radio waves. Similarly, matter waves, then it is 10⁻³ to 10⁻⁵. Okay, earthquake, then matter waves are there. So its wavelength is large in kilometers. Microwaves, then its wavelength is decreasing. Infrared, again it is increases. Decreases, 10⁻⁻⁴. Visible, 10⁻⁻�6. Onwards, -7, -10 and -12. Gamma rays, -12. Now, this is the wavelength. Its wavelength is less, energy is more. Okay, wavelength is less, then energy is more. Mu is equal to C by lambda. This mu is nothing but frequency. Frequency is equal to C by this wavelength. If is less, then frequency will be more. If frequency will be more, that energy will be more. E is equal to h mu. Second, if you convert this wavelength in nanometer to frequency, then its frequency range is higher. Okay, by this equation you can convert. Mu is equal to C by lambda. C value is 3 lakh km per second. That value you put and this lambda value you put, then you will get the frequency. Radio frequency is 10⁵ to 8. 10⁵ to 8. Second cycle per second frequency. Microwaves, then it is 10⁹ to 10. IR, then 10⁻12 to 13. Similarly, visible region, then 10⁻13 to 14 cycle per second frequency. Ultraviolet 16, gamma rays 17 up to, and X-rays and gamma rays is more than 20. So you remember, if this frequency is increases, energy is increased. Which region is used for which purpose, that we discuss. Suppose it is radio waves, then it is used for signal purpose. Okay, radio transmission. Second, microwaves, then radar. Where radar signal transmission is there. Second, IR, it is used for heating. Okay, IR1. Infrared. Infrared phones are also available previously. That is IR region, infrared. Again, infrared. Here this lambda is less, remember this. You compare these two regions. Visible region. Okay, visible region, IR region, less energy. Okay, IR region, less energy, and ultraviolet more energy. Okay, you remember it. Wavelength is less, but energy is more. Again, visible region. IR region is used for reading. Okay, IR1. Visible region, then illumination, light, simple light. Our eyes can detect this region only, and that is Vibgyor region. This Vibgyor region in nanometer I am telling. In nanometer it is around 450 nanometer to 750 nanometer. So remember this Vibgyor color, it is of 7 color. So violet, indigo, blue, green, yellow, orange and red. So this Vibgyor color means visible, then its wavelength is from 450 nanometer to approximate 450 nanometer to 7. Ultraviolet light, it is used in germiciding lamp. Okay, germiciding lamp to kill mosquitoes and insect. This ultraviolet lamp is used. X-rays, it is used in hospitals. Okay, in orthopedic device. Okay, bone crack, the X-rays are there. So in that its wavelength is less but energy is more. You can see 17 to 19 frequency. And last one, that is gamma rays. It is used for the treatment of cancer. So in cancer, these gamma radiations are injected to kill the cancer cell, okay, in our body. Cancer cell will there. If you pass this gamma radiation, then that cell will die and you can treat the cancer patient. So these are the different regions. Next time we discuss about the particle nature. Particle nature, remember, E is equal to Sc by lambda. And then after we discuss the dual nature. This light has a dual nature, wave nature also and particle nature also. Again in short, I revise the wave nature. Wave nature, you must know the velocity, frequency, the amplitude, intensity and wavelength. Second, its propagation. Electric magnetic field is perpendicular to each other and this term. Okay, region, different regions are there, that is radio, micro, IR, visible, you remember this, visible and ultraviolet energetic waves and IR less energetic wave. Okay, and last is this Vibgyor, 7 color from 450 nanometer or approximate 400 to 700 nanometer is there. You can convert into frequency also. So these are the region. Next time we discuss about particle nature of radiation. So you go through this, okay, try to solve the sum related with this, and this table is very important. This Vibgyor table is also important, which region has how much nanometer and how much frequency. Okay, try to note down in your notebook. Thank you.